All right, let's talk today about abstractions. You need to learn to think about abstractions in your code. This is one of the most important things you can do to get better at writing software. If you are an early career developer, especially if you're self taught, this is one of the most important skills you can cultivate to write better software. Abstractions are the decisions made by the software developer that hide unnecessary details and complexity from the consumer of that code. Now, not the end user, not the user of the application, but the consumer of the code may be the very same developer using it somewhere else or that developer's coworkers. You're talking about how to write code in ways that it can be utilized without having to know a whole bunch of stuff. um, Good abstractions reduce cognitive load and make it obvious which piece of code is responsible for a particular bit of functionality. So there's an art to it and it takes practice, and you're not going to learn it all here in this video. But I want to start off by demonstrating one of the most common pitfalls I see from early career devs and how to refactor that into something that demonstrates better abstraction. So what we have here is a very tiny little toy application. It's just a browser-based stopwatch, so I can click start and it will start ticking away. I can click stop and it will stop. I can click reset and it will reset. I can click start again and it will keep going. If I click stop and start again, it will continue to tick, and so on. So if we look at the implementation here, it's all kind of jammed into one file. And it's reasonably manageable because this application is so simple, but there are some major shortcomings here. So the basic implementation is I grab references to each of my three buttons and the timer display itself, and I attach event handlers to the start button, the stop button, and the reset button. With each one, I am guarding against the whether or not the timer is running. So in a start button, I don't want to do anything if the timer is already running. So I am checking to see if we have already created an interval. So that is the JavaScript interval. That's a repeated invocation of this function that has been hoisted up here to the top of the file. In that interval, which runs every 1,000 milliseconds or every 1 second, I am incrementing this time elapsed variable. I am taking that integer and formatting it into something that displays nicely. So that's our 00 : double whatever, or minutes and seconds, 2-digit minutes and seconds, and then taking that friendly display value and putting it into the inner HTML of time display, of my time display element. And then I am setting the disabled attributes appropriately for the start, stop, and reset buttons based on whether the timer is running. Very similar implementation here for the stop. I am guarding against whether we're already running by using the interval. If we have an interval, I'm going to clear it and then set it to null. So that is effectively stopping the stopwatch. And then again, setting the disabled attributes appropriately. Reset is going to, again, we can't use it if the interval is running. And it will set timer elapsed to 0 and set the timer, the inner HTML, to something friendly here. So it works. It works fine. However, there are a lot of problems with it. The thing that I don't like about this, in the thing that would make it difficult to maintain over time, as we added something more than just toy functionality, as this were integrated into some actual application, the main problem here is that we are combining the two responsibilities: one of interacting, of dealing with user interactions and displaying information back to the user, dealing with the UI layer. And then also we are dealing with the actual manipulation of the timer. We are setting and clearing the interval. We are formatting the time elapsed, but also incrementing the time elapsed. All this stuff is getting jammed into these event handlers. And so this is the big pitfall that I see very frequently in early career developers' work is because the UI layer is the first piece of code that you implement. Usually you're working, it's the first layer that you have to write up in order to get something to display. You start jamming all of your logic right there into the UI layer. So a good first step to finding usable abstractions, one that I often use for myself and espouse as an exercise for people, is to extract everything you can out of the UI. So you want to get the thinnest possible UI layer and then figure out what you would need to expose of the remaining logic in order to get that job done. And so I'll show you what I mean. So if we were instead to get rid of our naive implementation here and use instead UI.js, I'm going to start working with a, a fictional timer class. So here's my timer.js and my UI.js. These are my two concerns here that I'm going to start to spread apart and find as firm a line between them as I can. So I know anything that is dealing with user interactions and displaying information back to the user goes in UI.js. Anything that deals with the actual responsibility of keeping time goes in timer.js. And I want them to be loosely coupled and clearly demarcated. So one way to do that is to start with basically a fictional or an imaginary implementation. So we can say import timer from timer, timer.js. And just so we don't just get an error, I'll say class timer. um, and if I'm going to write out UI.js, I'm going to write it as though I had this timer class and just start sort of writing out methods on that timer class that I might want available to me. So probably going to start with the same four elements in my UI, right? I'm dealing with the UI. I want references to my same four UI elements. And I'm going to have similar start button, stop button, reset button, the event handlers on those. So we'll say start button dot add event listener, click. I want to say const timer equals new timer. I want a new instance of a timer. So I have, again, this blank slate imaginary thing. All I want to do here is say timer.start. Right? So this is the beginning of my abstraction. In my UI layer, I don't care how a timer is started. I am simply calling timer.start. Whereas here in our naive implementation, what we have is this implicit is timer started. I don't know, because interval, like I'm using the interval as a way to know whether the timer is started. But it's not explicitly stated that that's actually what the timer means. And so um, that would not scale over time. Another developer coming in here wouldn't necessarily know that that's how we are checking if the timer is running, and it becomes very prone to errors and bugs. So instead, what we want is that logic encapsulated in an object itself. And so we can have similarly start button, add event listener, click, stop button, add event listener, click, should just call timer.stop. So we want this thin UI is capturing events in the interaction layer, capturing user events and forwarding them on to logical entities that are actually going to do the work. So reset button, same thing. Add event listener, click, dot reset. And you notice here, I don't have to do any guarding of whether I'm allowed to call start, stop, or reset. I'm going to move that logic all into the timer. The timer will be the arbiter of whether this works or whether this is permitted. So if I now want to go over to our timer itself, we can actually move a lot of this logic into sort of extract it from our naive implementation and divide it off into the timer itself. So the timer is going to have public methods called start, stop, and reset. We know this already. And in order to encapsulate that behavior, we can create some private instances, some private methods and properties on here. So for instance, the time elapsed and interval, these now, well, leave those there, but these now get hidden away as private methods or private, excuse me, private, um, oh my goodness, private properties in the timer instance itself. So nothing needs to know whether there is a browser in whether there's a JavaScript interval created. That is an implementation detail of the timer itself. And similarly, time elapsed, uh, we will see why we're going to hide it away in a minute. We don't want it to be public that can be manipulated and changed imperatively by other consuming code. We want to just have it readable but not writable. And so we're going to create this private instance, this private property. So we can say in our start method, we will do very similar logic to what we have here. If we'll check on the interval. So again, this is a concern of the timer, not a concern of the UI. So we move this and hide it away in the method. So if this interval, we're going to return false. Otherwise, we're going to return true. So this will be a pattern I'm going to use for all of these methods, which is to say, we'll give back a return value to let the consuming code know whether some action was taken. So if there was already an interval, meaning if we have already started, we will return false, indicating that this was a no op. Otherwise, we'll return true. So then we'll say this dot interval equals set interval this time elapsed plus plus, and then for now, that's all we'll do. Stop is going to similarly check against this dot interval, but we want if no interval, return false, otherwise return true, and this will clear interval, excuse me, this interval, and say this dot interval equals null. And again, we will just hold there as that's enough for the moment. And then reset button, we will do a similar guard to starting. If it's already running, false, return true. This dot time elapsed equals 0. That's all for now. Did I mistype this? Why is this telling me? No, that seems all correct. Okay, so I'm going to, right now, our timer, the only thing our timer does is start this interval and increment time elapsed. So what I'm going to do for now is just console.log this dot time elapsed and make sure that that works. So if we go back here and refresh here, inspect this. requested module timer.js does not provide. Oh, I didn't export it. Again. That's interesting. Huh. I am getting interesting. I am getting some console clutter from the extension that I'm using to record this video. That's fun. Well, we'll see how this goes. So now if I click start, well, we can see one thing that's wrong, which is that I did not set a time for my interval. And come back here and hit reset and try again. And now we're seeing great. Our timer is incrementing once a second. I can click stop. I can click reset and start again, and it should start again at 1. That's great. I can click stop. I can click start again. It seems to be working fine. So from here, I'll stop this. This is great, but we don't have any way of displaying the time in our timer. So what the other thing I would probably want to do here is something like let's call it like timer.onClick. No, sorry, not onClick, on tick is what I meant to say. So basically registering an event handler. So every time the timer ticks, it will call these callbacks with the elapsed time. And so from here, I would say, I will pull this logic from our naive implementation because this is UI logic, right? This, all we're doing, the timer is dealing with keeping track of how many seconds have elapsed, and our UI is in charge of taking that and turning it into something that is displayable to the user. So this feels like decent UI logic. So I'll say timer.onTick, do this, which means I need to go here and implement an onTick method, which takes a callback and will register that callback in a private array of handlers. So this simply says this dot tick handlers dot push callback. But then what I need to do is create a private method on this timer called emit tick. So this is going to be something I can call from within the timer. It's not something at this point that I need to be able, that consuming code needs to have any notion of. The only thing we need to do is have some way of from within the timer calling all of these registered tick handlers. So what we're going to do is say this dot tick handlers dot for each handler handler this dot time elapsed. So for any handlers that we register using onTick, every time we call this dot emit tick, it's going to call each of those handlers with the time elapsed, that the current time elapsed. So that means every time, instead of saying console.log this dot time elapsed, we can now just say this dot emit tick, and that should run this callback here on every tick. So let's see how this goes. I'll give that a save. I'll give this a refresh. Not getting any errors. And I click start and bummer. Time elapsed is not defined. Oh, because I am using the wrong variable name here. Say elapsed. We will say elapsed here. And if I click start, now we should see excellent. All right, so our timer is running. I can click stop and it stops. I can click reset, but it does not seem to reset. And that is because when we click reset, we're not actually emitting that tick. We're not emitting, we're not, because we're not emitting that tick, nothing that is using this code has any way of knowing that the time elapsed has changed. But you'll see I have hit reset, and if I click start now, it will start over at 1. So what we want to do here is come down to reset and say this dot emit tick. That should, yeah. We'll say stop. We'll say reset. You can start again. Excellent. Okay. Now the final piece, well, there's a few pieces still, but the biggest final piece is you'll notice that the start and stop and reset buttons are not changing their enabled state based on whether the timer is running. So we need something similar to the on tick. We could do on state change. Just like on tick, we'll say this dot state change handlers dot push callback. And what we want is if we were to, we want a derived property called state. So you'll remember in our naive implementation, what we're using all over the place is if interval. If the interval is present, we are running, otherwise we are not. And we're doing all sorts of checks against that. But really, what we're actually conceptually checking for is our timer running? And so the consumers of this code, of this timer object, don't care whether we're using an interval. And down the road, we might come up with some other way. And in fact, I will show you a very good reason why we should come up with another way of checking whether the timer is running. So in fact, what we want is in the public API, we want a property called current state. And we'll use that to check whether things are running. So that will be a derived property. We'll say get current state return if this dot interval, we're going to return running. Otherwise, we're going to return stop. And so what this does is insulate the consuming code from changes in how we determine whether this is actually running. If we change the implementation of this so that we're no longer using an interval, we can still have this public property. This is not going to change. We still have this notion of is it running or is it stopped? So that means we can actually use that internally as well. So we can say if this dot current state equals running. And so this becomes a little bit more explicit in our intention. So yeah, this makes it clearer in our intention. And again, insulates us a bit from implementation changes if we decide that the interval is not the way to go down the road. So now we've got our state change handlers. We want a similar private method called emit state change, or maybe just emit state. And so then we can say this dot, we need to add state change handlers. So this dot state change handlers dot for each handler handler this dot current state. So just like the emit tick method, this will call every registered handler with the current state whenever we call emit state, which means we can go down here, we'll say this dot emit tick, this dot emit state. Similarly, stop this dot emit state and reset. Reset doesn't really change state, but it's not going to hurt anything. We'll say this dot emit state, which means that in our UI, if we go back here, we can say timer dot on state change state switch state. You may have heard me rail against the use of switch cases, but this is actually a pretty good use case for one. Case running. Always wrap your cases in curly braces because it scopes whatever you're doing to the case itself. So you can block scope using, excuse me, so you can use constant let, and things that are block scoped will be scoped to that case, not to the entirety of the switch statement. So we'll say case running in here. If we are running, we will set our button states accordingly. Case stopped. Oops, and we need to break. Case stopped. And I'll come back here and say set appropriately here. And in our default state, we will warn non-state state. So if something gets passed in here, it would be unexpected. We don't know what we're getting. If it's not running or not stopped, it is being used inappropriately. So we're going to warn about it. So this should, in theory, take care of the button visibility or button enabling. So if I click start, we'll start up. If I click stop. Now, did you notice something? When I clicked start, they didn't change until the interval started. That tells me that I actually, yes, this should not be in the interval. This should be down here outside the interval. And so now we have usable timer. Everything seems to be good here, behaving as it was previously. Yes. So now there are a few things here that I will draw your attention to sort of going forward. So the first is the timer on the right is not the most idiomatic JavaScript one could ever write. There are probably things you could do to make this a little bit more idiomatic, a little bit less repetitive. And that is just the nature of writing software over time. What we have done here is by moving all of the logic that is just around the timer into the timer object itself, it makes that task much, much more straightforward down the road. If you're like, oh, I want to refactor this, I want to change how this implementation works, or I don't like the way that, I don't know, we're using the emit tick. I think there's a different way that I want to go about this, or whatever, that logic becomes encapsulated here in the timer, and it does not change the code for anything else that's using the timer, right? It becomes only a concern of the timer itself, because as long as the public API doesn't change, so the start, the stop, reset, on tick, on state change, that's all the public API, the public abstraction here. And then the other thing I will point out is that there is, this is sort of a prompt for you, is that there's actually a huge bug in this, in our implementation with the set interval, the way we're using set interval. And that is, if you notice, when I click start, 1, 2, 3, 4, just before 5, I click stop. That clears our interval completely. And if I click start again, we theoretically stopped at, say, 4.9, right? But if I were to click start again, it's going to start up this interval again and not tick again for a full second, which means we're losing time. So if I click start here, what should have been a tenth of a second before we hit 5 is actually a full second. So we're losing time there. There's no super easy way to do this. The logic for handling this starts to get pretty gnarly, because what you're actually going to have to do is set up an interval that's checking against time elapsed against a start time. So when you click start, you're going to save the start time. And then in your interval, you're going to check time elapsed against that. If you click stop, you're going to have to somehow deal with the fact that now you have some amount of time to add to whatever amount of time you're going to continue to track when you click start again. So that logic starts to get pretty gnarly. It would have been a whole lot more gnarly if it was over here in our UI, but now it is tightly encapsulated in our timer class, and keeps things nice and tight in the implementation here. So I leave that as an exercise to the viewer. See if you can figure out how to track this in a way that doesn't lose time if you click stop and start again, that doesn't lose the remainder of an interval, doesn't throw away whatever part of the interval that didn't tick over. Yes, hope this was helpful, and we'll see you next time.